be talking about Lua, and I'm not going to have time really to talk about how you program in Lua. This is really just specifically about the situation where you have a game already, or you're looking at writing a game, and you want to add in Lua support into that game. So, you know, if you're looking at things like Corona, obviously, you probably know that you can write a complete game just using Lua without ever, you know, having to interface with native APIs. Lua can be pretty powerful. What I'm talking about here is just taking a game that you've already got and using Lua in two different ways. First way we're going to use Lua is where we have an embedded ability inside of our code to run Lua scripts. So we use that to host a Lua script that we run and we do interesting stuff with. And then the flip side of that is where Lua scripts or scriptlets that you have embedded can actually call back into your game through an API that you build to actually run functionality from the game. I'll try to take questions at the end. If you've got something that's really eating you up, please shove your hand up. But I'm going to cover pretty much everything on this topic. So if you've got a question, there's a pretty good chance that it'll get covered. So hopefully I'll get through it. And also, I've got more stuff on my blog. So I have a bunch of stuff up there. Go check that out. Also, I've put the code for this whole tutorial on GitHub. And the final slide will have the GitHub URL where you can actually download this and play with it yourself. So the reasons to use Lua is it's fast and small. At Nokia and Trolltech, when I was working with Qt, we actually integrated the V8 JavaScript engine, which is the Google one using Chrome. And it is really fast, but it is not small. And it's really a huge pain in the ass to actually embed it inside your program as well. There's quite a few cross-compiling issues. So if you go into an ARM core device, suddenly you've got a lot of messing around that you're trying to do to actually get that thing compiled. So Lua has some pretty attractive attributes, and hopefully I'm going to show you how easy it is to actually get it installed inside your code. And of course, you know, why would you want to use a scripting language at all? There's a few compelling reasons. You've probably already thought of most of them, I think most of you guys are coders. But scripting languages, you know, apart from the fact obviously you don't have to compile them, it's really nice being able to embed them as a text resource in various assets of your game. You can update parts of your game using, you know, text uploads or pull stuff down from, you know, some patch that you have on the web without having to recompile. Depending on what sort of store framework, whatever signing you're going to use, there may be issues with actually changing your binaries. So scripting can be pretty nice, and we'll do a little bit more on this topic once we get into it. What I'm going to cover, as I mentioned, is getting Lua into your game, which is really pretty simple due to the fact that it's just portable standard 99C without any real dependencies. We're going to then look at running the Lua interpreter, so your runtime of your game becomes a host for Lua, and as your game is executing, it's going to be running Lua. And we're also going to look, as I mentioned, at adding a Lua API. So the things I'm not going to cover, I know a lot of you guys work with Unity and other frameworks. It is possible, I have a bit of a hunt around to actually embed Lua inside C# in a very similar way to the way I'm going to cover here. Same sort of thing with Java. You just need the ability to actually call into compiled code. So obviously your Lua code is going to compile down to whatever your platform's object format is for a C binary. And there are ways to actually get that stuff running inside of Unity. So one thing that can be very tempting when you first start looking at Lua, and I did look at this myself. Come on in. grab a seat. There are generic binding frameworks. I don't know if you guys have ever seen Swig, which is one for Perl, but the idea of these generic systems is it's going to take all of your APIs in your game and then magically produce a Lua binding. Magic can be good if it works. I'm going to suggest that this approach is much more lightweight, because if you're looking at using Lua because you don't want to introduce a whole lot of new dependencies, you don't want to bloat, manually creating your own APIs in the way I'm going to show you is really, really powerful. You're not going to lose a lot of performance. Some of these binding frameworks, they may work. I can't attest to whether or not they work, but I do know this method works. So that's what we're going to cover. For the C# folks, please have a look, and I'd love to hear if you manage to get this kind of approach working, because I believe it will work, but I can help you out on the list and stuff. But,
I only just noticed the last couple of days actually on Unity Reddit that someone was talking about running Lua under Unity. So if anyone wants to do that, go and look at Reddit.
Yeah, I have seen a few things out there covering this. Okay, so what I did as a case study, because I wanted to cover this topic with something that was actually going to give you a real crunchy little example that would work really well. And I've taken something from my tech stack because that's what I know the best. So I'm using Cocos, and I use Cocos Builder, which is a nice little graphical tool that allows me to assemble graphical elements together, and then they get compiled into a resource file that then gets dropped into my project, and Cocos then calls into those resource files to load that stuff up. So I used a project that Victor Lidholt, the guy who's the author of Cocos Builder, he created this Cocos Dragon tutorial, and I wanted to be able to use some materials that were going to be open source, so I'd be able to put the project up there for anybody to grab hold of. So basically what I did was I took Victor's raw project and added a few updates. I made it run on the iPad, so he's written it as an iPhone game. I added a little bit of music and a few other bits and things. I had a little cheat mode to make it easier, because it was kind of a really hard game in the way it was hard and easy at the same time. But obviously, once I got to that stage, I sort of freeze-dried where I was at, checked it all into GitHub, and then from there I went on to actually create a scripting framework. The thing that inspired me to use Lua in the first place was that my own game, this is actually going to work for me. I use Lua in a slightly different way, in that what I do is, my game's an adventure game. Audible. You won't be able to see that. I'm sort of purposely being a bit obscure, because a lot of this stuff is going to change, but it's a noir sort of thing, detective stuff in the city and Blade Runner-ish sort of themes and stuff. And in the adventure game, a lot of state about the game changes. So what I wanted to be able to do was, at runtime, I wanted to be able to query the state and then actually be able to sort of change the behaviour of stuff based on what the state of the game was. So let's have a look here. I should be able to. Okay, so here's my little pillows that I've selected. I'm going to try and examine the pillows. Now I've got some text here, so it's displaying the pillow, but then there's a bunch of text. Now what I've done is, inside of my game I have an XML resource file, and the text is saying, there's some blood stains on these pillows. So what I do is, inside of the text resource I have $curly brace scriptlet, and that's just embedded inside the text. So say I was working with a game designer or level editor, that person could drop an expression into the middle of the text. And, come on in, grab a seat. I think that was free. And that gives me the ability to sort of quickly and flexibly change the actual appearance of things. Also, I can select the way some of the sprites appear in the game based on the attributes of the game at runtime. So what's happening there is Lua is calling back into my game through from Lua, bridging across into the Objective-C runtime of the game. So that's one approach. A very similar approach that I'm going to take when I go through this Cocos Dragon example is, very similar sort of principles. So let's see if we can show you how this works. So this is the base. I'll just quickly look at, so this is the final version of the game. And if you go to the GitHub, you'll see, this is the version you'll see, but you can just roll back in the Git history to get the version without the special scripting source. Hopefully I haven't broken anything. This is actually going to run for me. To get to this point in Victor's tutorial, all this basically is I've got the URL for the tutorial, but really all I did was, as this README says, I basically typed in the code from his tutorial straight into the top of the stock standard Cocos 2D template project. So you guys could easily get to this even really with not knowing any Objective-C just by following his project. The things that I added was I added in this cheat mode thing, and what that basically does is it looks to see, well, dealing with a little tiny screen here. So if cheat mode is set based on an argument on the command line, well then I'm going to add in a whole bunch of extra coins, because the dragon flies up the screen and he's got a munch on coins and that allows him to keep flying. So I'll just see if I can actually get this to play. Okay, so I don't have my device connected. I'll try and use the simulator. Some screen size issues here. So, as you can see, these bombs are now chasing me. Luckily I've got my cheat mode coins down the bottom there to help me out. Oh, bomb! Damn! So that's basically the game. Very, very simple. There's not a lot built into it. But the important thing to note from that little demo is that those bombs were exhibiting some more advanced behaviour. So if I put out of that advanced version, what I did was I created these two scripts here. One is for this seeker bomb, which is those guys you saw right at the beginning, and I gave them a different icon so they look a little bit different. And it's really just doing some very basic chasing behaviour. And I'm making a couple of lure calls out here to an API, which I'm going to show you how to create. And then there's a lurker bomb. And what the lurker bomb does is, if the dragon's further away, what it does is it goes up and it finds the final coin that the dragon has to get to in order to solve that level. So there's this final end coin, and that's usually right at the top of the screen. So the lurker bombs go up there and basically hang around waiting for the dragon, so they're lurking there and wait. So you've got two moderately sophisticated behaviours, certainly a lot more sophisticated than the behaviour of the original game, which I'll just show you this stuff. So I'll just duplicate this because I'm going to make these mods to it. This thing too. So I still have my cheat mode. Down. And this one, notice that the bombs are not trying to chase me or follow me. Basically just sitting there waiting. Really not very clever at all. If I was better at playing the game, I could actually basically go all the way up the screen without really having to worry about those guys chasing me. So this is the original version of the game, and very simple behaviour because the bombs are basically these static objects that are just appearing on the screen, and you've just simply got to just try and avoid them. So we really don't have a lot of screen real estate here, do we? So this is our standard sort of template. You can see there's a few game objects that have been added to it. Otherwise, this is the basic sort of thing that you get when you build a COCOS game. The COCOS library has been installed in here as part of the template. And the only other thing I've done is added in the COCOS builder import code, which allows me to read in COCOS builder files. And then on top of that, I've typed in the material from Victor's tutorial. So in order to actually import Lua, we just want to download the actual source, which is going to be our Lua source code. You don't want to have the binaries at this stage because of the way we don't work with them. And in here I've got my, my Lua code, so just expand it out, and let's see. I'm used to my 27-inch cinema display at home. I feel like I'm squinting at this thing through a keyhole. So here's our expanded out Lua code, and the process of getting Lua into your program is pretty simple. First thing you want to do is just rename this directory to be Lua, and inside here you're going to want to delete 3 files. So Lua ships with the Lua compiler. You want to get rid of that two reasons. One is that if you're ever working with compiled Lua on your system, you're going to have a lot of portability issues if you ever go to an embedded platform. Lua really just does not support compiling Lua and then transmitting it to a different platform other than the one that you compiled it on, and then running it from the binary. But the whole reason we want to use Lua in the first place is because it's text, and text gives us that dynamic ability to change stuff. So why would you want to compile it anyway?
Is it just the issues with the endianness that cause problems?
There's endianness and int size and a couple of other wacky problems that it has.
Do you know if it doesn't get cross-compiling? Like, is it actually possible to configure it to cross-compile?
I believe you could get it to work. If you're porting to multiple platforms, you may have some issues with it working, say, on Android and then not on Apple or something like that. So, my suggestion is just do it all as a text. I mean, you can always compress it, right, if you're worried about the size.
And the compiler presumably is very fast then?
It just means that what it's compiling it to, like Lua uses it's actually a really nice example of compiler writing. So if you look at the Lua engine, it's a really good example of how to build an interpreter. And it compiles stuff. Sorry?
I was going to say, I've looked at the VM before, and the VM's elegant.
Yeah, it's a stack engine, and it's classic stuff. Performs quite well, and what it's doing is basically compiling everything down to byte codes. So you've got data and byte codes embedded in there. But anyway, I'll just I just want to get too bogged down to that. So we'll remove the Lua compiler. The other thing is that if you want to fool around with Lua on the command line, you can use the command line interpreter, which is quite nice. For our purposes here, I'm going to get rid of that. We could just leave it there, but the problem is it defines a main, which is the entry point to your compiled program. So that's going to clash with the main symbol that you already have in your program, so we want to get rid of that. And lastly, we want to get rid of this make file. So now that we've got all of that stuff, let's see if I can put this into my project. Normally I would just drag it and drop it, but I don't have enough screen real estate to really put it up. Let's see. Get it to copy it in there. It's going to be part of our main project. So because Lua is just pure C, it actually compiles really easily. There's a whole bunch of warnings that are going to come out of Cocos. But I found that Lua is almost completely clean. Let's see if I've actually broken anything and if this is actually going to compile for me. So, a few warnings out of Cocos, but Objective-C had no problems munching on that, and nice clean compile. So that's basically all you've got to do to get Lua into your code. Obviously now it's not doing anything, it's just sitting up there taking up space. You could try to compile it as a static library, you could mess around, but that process is so simple that I'm going to suggest there's not really much value. If there's a security problem with Lua and you need to go to the next version, that's so quick. Like, why would you bother messing around trying to upgrade libraries? So, alright, so we've got Lua in there. It's really not doing anything for us at the moment. Let's go ahead and get Lua working inside of our code. So I'm going to add in a little Lua interface. So I'm going to add in a new class, and it's going to be a Lua engine. Yeah, sure. Now, here I want to just include or import Lua. And what I'm going to suggest using is this nice little C++ interface. If you're doing this for managed C or for C#, you're probably using the exact same thing, this .hpp. And inside of here, all that's really doing is just doing an extern C and pulling in that code. Right, now, this is a slight catch, and it's going to depend on what platform you're using. At the moment, this should compile, right? Let's see if we can build this. Now, we're going to get a failure here because, wait, I can't understand what this extern C crap is all about. The problem is that inside of our code here, we've obviously imported some C++ stuff. C++ is going on. And in order to make Objective-C handle these different compilation rules, we're actually going to need to tell Objective-C to compile this thing as Objective-C++. And the plus means do Objective-C things and also do C++ things. And if I do that, all I have to do in Objective-C is tell it that it's an MM file, and that will, the makefile rules that Xcode generates will actually use the appropriate compile time switches, and we get our engine happening. So that'll vary on your platform if you're working with Java or JNI or whatever. You want to do something similar to actually get that to compile. So inside of here, we're just going to have a couple of standard sort of accessors to get hold of our engine. And, we're also going to have something to actually run the runtime, our Lua runtime. Go over here and implement those. Now what I'm going to do is I'm just going to, you've seen the target that we're trying to get to, the ability to run those intelligent scripts. I'm just going to keep coding until we get low on time. So if I start getting too close, I'll just cut back, and hopefully we'll have enough of everything covered that you guys can make sense out of how I got to where I got to. So I'm just going to implement this quickly here. This is just a standard sort of Objective-C singleton. Here's a nice little template they give us. It's going to be equal to our Lua engine. Allocate one of them. Initialize it. And return it. Oh, if anyone sees me make a mistake, which is almost bound to happen, please just scream out if I miss it.
How many other people here know Objective-C?
Very little.
If anybody's curious, please just yell out. But anything's, what the hell is that doing? Dispatch is just using Objective-C's Grand Central Dispatch, which is its threading thing that comes with Coco. Pretty cool, but it just happens to have this nice little singleton recipe. So that's how you code up a standard singleton in an Objective-C. And here's our run Lua. Okay, so inside of run Lua, what we want to actually do is, I'm just going to refer to my little cheat sheet that I've got here. Okay, so we want to create a new, actually, I'll put the init function. If I can manage to type today. Okay, so we're going to have Objective-C has this really weird model for public-private inheritance. So what I'm going to do is create what's called an Objective-C class extension. Don't really need to know what that is, but all you need to know about it is that it's equivalent to a private part of your class. Because this thing here is going to be compiled by our C++ compile rules, that is basically got to be an opaque black box. You don't want any other parts of your code and the rest of your program trying to mess with the stuff in there, because it's been compiled with different rules. So I'm going to do a little bit of extra work to just make sure that the instance of our Lua runtime is actually going to be hidden away inside of here. And the nice thing about Lua, it's actually pretty cool, is it's completely re-entrant, and the way it manages that is everything to do with the status of Lua at runtime is stored inside of this block of memory, and you actually explicitly pass that chunk around from function to function. What that means is that you can basically say, well, here I am in this thread or context or whatever, and you know exactly where your Lua is at. It's you know, you can be in some thread. There's no threading issues because you've got the data right there, and you can just pass it explicitly. And that data is obviously this pointer to our Lua state. So we're going to make our Lua state equal to a Lua under new state. There we go. Oh, no, that's not what I want. Yeah. The Lua API is pretty cool. I recommend, if you're going to actually get into Lua, buying this book. First thing about it is that online the Lua code is, the Lua references can get a little bit dated quite quickly, so you're going to see stuff out there that actually refers to different earlier versions of Lua. The other thing is it actually helps out the Lua project, because those guys are working their asses off to produce great open source software. Why not give them a little hand by buying a book? I bought the Dead Tree version, but I think you can get it on Kindle and stuff as well. But all of the APIs are described there in the book. In particular, in the back section of the book, there's a really, really good chunk on how to integrate Lua into your program. Any of the Lua functions that are using library code are going to have an L at the back. If I use a function that doesn't have the L there, it's actually kind of raw, low-level Lua stuff, so that's getting down and dirty. So all I'm doing there is creating a new Lua state variable. And the only thing that can really go wrong with that is that maybe our Lua state, there wasn't enough memory. So, oh, my fingers. So we'll check for that. And then the last thing we're going to do is set up Lua. And this is the first example you're going to see. You'll see a lot more of this, of how everything we do with Lua is passing around this variable. So I got my Lua state, I pass it to Lua and say, hey, go do this, and here's the state. Lua, as I mentioned, is really small. One of the reasons is that by default, you only get the actual runtime. You don't even have the ability to print stuff out, to stand it out. It just comes with nothing at all. So there's a whole bunch of different libraries, like the math library and all of these sort of things. If you don't want them, you don't have to have them. You can pick and choose. OpenLibs just takes a standard menu of, like, I think 4 or 5 of the core Lua libraries, the ability to read environment variables, a few other things like that. It's just going to open those up for us with one nice little call. So that's setting up our Lua runtime. And then down in here, what I'm going to do to actually run our Lua program is I'm going to actually run a script which is going to be do files. Thank you. Xcode. So Xcode's interrogated and indexed the Lua API for us already, which is kind of nice. Again, we're passing our Lua state, and we're going to have a Lua configuration file. So this is an example of actually running a Lua file from our Objective-C. So we'll call it the Lua config. Let's see, our Lua config is going to be a file we get out of our bundle. Which is going to be a path for resource. It's going to be config, and it's going to be a file extension of Lua. Does that make sense? This thing is a NS string. Whenever you're working with Lua, and this will be the same for your objective, for your C# or Java or whatever, you're going to need to have to pass in a standard null terminated C string here. So I'm going to tell this NS string to get itself a C string. It will be the default C string code. And we'll create our Lua config file inside of our resources directory. It's just an empty thing here. We'll call it, what do I call it? Config.lua. Not luau. I have a Hawaiian themed program, but that's something different. Okay, so print. Lua config loaded. That's something extra special. It's you. Shut up. Okay, and this is going to be a configuration file, so let's try to actually configure something. And this is why I set this cheat mode. I say here, let's say cheat mode equals true. So this is we're going to read out our cheat mode theoretically from this file. So in order for that to actually happen, I'll just go into my schemes here and my runtime edit, and we'll get rid of that argument that's being passed in there. So we're going to run Lua. Let's do that inside of our app delegate here. When our application has did finishing with launchings, much to the glory of launchings. I need to move this at the top. Lua engine, which is going to be our shared engine, and we're going to run Lua. Okay. Let's just have a tiny bit of error checking here. By default, as I mentioned, Lua uses this stack to handle everything, and we'll pretty quickly get au fait with how Lua uses the stack to pass everything backwards and forwards. So in this case here, it uses this idea that of passing a non-zero value back in the case of an error. So we're just going to say ns log could not run script, name of script, and then error. Now here, this is again our issue where I'm using an objective C string versus a standard C null-terminated string, because that's what our error is going to come back as. So our Lua config file, and our error is actually going to be, just think here, so we want a Lua toString. So what this function is doing is going to the Lua stack, which is captured inside of our little, so there's our magic library of state, of our Lua state that's going to appear everywhere.
I like to think of that as the virtual machine that's actually running the scripts.
Yeah, that's basically what it is. It's like the brain of the virtual machine, so that's exactly what it is. So that's going to be our Lua state. And, okay, so what the hell are we going to put in here for the value of this I? So this is obviously an index into that virtual machine. And -1 is just going to give us the last thing, the thing that's on the top of the stack. And in the case of there being an error, Lua is going to very handily stick our error in that position for us, which is pretty nice. So we'll handle all of our error inside there. What have I forgotten? Let's see if this actually works. Time to sacrifice our chickens.
So does the stack always have strings on it?
It'll only have what's placed there by Lua. Lua's really good at always trying to so that's a little bit weird. Why do we still have cheat mode? Yeah. Yeah, I did, but we haven't actually evaluated the value of that variable yet. So. Okay, moving right along, nothing to see here. Okay. So it's doing something good that it shouldn't be doing. Anyway, let's see. Okay, so we've got our Lua config loaded, miraculously enough. So we executed that script.
Did you maybe not do a full clean rebuild?
That could be it, yeah. Yeah.
That's always the thing these days. When in doubt, do a clean rebuild. It fixes so many bugs.
So when I was building, I've sort of created a fresh duplicate of that base project, but there may be some relics lying around inside the emulator or something. So, in fact, let's see if we go run.
I still find it stunning that the proper dependency tracking seems to be an unsolved problem.
Yeah.
Like, programs don't rebuild properly.
I should go let's see.
So the cheat mode on down the bottom.
Yeah, that's right. So just get rid of this and all of its data. That might help us out a little bit. All kinds of random crap here.
This is how you know it's a real web.
Yeah, that's right. Don't try this at home, kids. Okay, so we've got rid of cheat mode now. Flying without wires. Crash and burn. Oh no. Alright. Okay, so we are actually loading our script, and that's good. That means we've got a few of the pieces of the puzzle together, right? We've got our Lua runtime. It's executing our script for us. But we've got to actually get some data out of it. So in order to do that, what we're going to do is interrogate lures stack a little bit more scientifically, and this is where you sort of need to start trying to imagine that virtual machine that Ash was mentioning. So we're going to get global, that's the one, yeah, real estate, and we called it cheat mode, and of course it's got to be a C-style string. Now what this is going to do is you might look at that and think, hang on, why isn't she assigning something to the return value? Well, that doesn't return anything. That's one of the things that you've got to get your head around a little bit with Lua, is every call we make is going to mess with the stack somehow, and then to actually get something off this stack, we use one of these Lua_to functions. So first thing this is going to do is say, okay Lua, runtime the virtual machine guy, go stick what I'm after onto the stack so I can get it off.
So effectively it's executing the virtual machine's get global function, which pulls a global onto the top of the stack.
Exactly, yeah.
So the toString function that you use just above there, actually, does that actually pop that value from the stack? Or
It does.
Right. I was going to say, because it sounds like if that's just converting something on the stack, you'd almost...
I think it's interrogating the stack without popping it. There are separate pop functions. So the standard idiom when you're writing these C interface functions is that you sort of interrogate the stack and leave everything in place. I took the approach with my Lua interface that I wanted to learn the minimal amount of Lua interface code from the dark back pages of this book that I could use just to get what I needed done. And it turned out to be quite a small amount, so there is some more sophisticated stuff you can do by messing with the stack, but I'm just going to interrogate it using the actual variables.
The interesting thing is that when you're pushing things on stack to get them into Lua, and when Lua's done some processing for you, you've got to pull them off the stack manually, and it's just like what programming used to be before high-level languages.
Yep.
A lot of people don't need to know that sort of stuff anymore.
Yeah.
It's a sort of a bit of a throwback, really.
It is. It's kind of, you're going back to the basics of computing, really. And like I said, there's a lot of educational value in looking at the code inside of the Lua runtime. But it is drop dead simple. It's like, steampunk chunks of stuff. And it all makes sense. It can be a bit obscure. Once you get used to this sort of idiom, it all just makes a gruesomely simple kind of common sense. So often you will find when you're coding this stuff, why isn't the variable I want there? Oh, well, I didn't put it there because I'm the one that has to take responsibility for doing that. So what I'm going to do here is like maybe when I wrote my script, I put cheat mode and I set it to be an integer. So what we want to do is just ask Lua, hey, is that thing a Boolean? What this is really going to do under the hood is say, can you force it to be a Boolean? So really, if it was an integer, it would kind of type munge it. But this is just a little bit of defensive coding, just to see if we can actually get some checking that was correct. And if it is, we'll turn it on there, and we'll get out the value. Is equal to, no, it's not objective C call, it's a Lua _to Boolean on our Lua state, and -1. Starting to make kind of crazy sort of a sense, is it?
What does the @ symbol represent before the string there?
So that is
Replace?
yes. It's basically a it's like a preprocessor directive to the compiler saying this thing is some Objective-C magic that's stacked on top of standard C. Because Objective-C is a superset of standard C. If I could write standard C, and in fact it's exactly what I'm doing with Lua. So the @ symbol is just basically that @ symbol is a processor directive saying go and create an NS string literal. NS string literal, so I don't have to actually create an NS string using a standard C constructor. The last thing we have to do is use defaults, the same kind of thing that we use to actually extract the command line. Set bool, I think yes, set bool, cheat node. So that's going to turn it on so that our code can actually get it out of the Hey, now we've got cheat mode back in. Thank goodness for that. Okay. And, okay, so there it was set. So now we're running code and actually doing useful things from Lua. So how are we going on time? We're at 1:05. I think if I just go for about another 10-15 minutes, I'll show you how you can add an API call so that we're actually able to pull back from Lua into our code.
So did you actually, did I miss that? Did you actually set that boolean to true within the script?
Yeah.
Yeah.
Oh, okay.
Yeah, I used the...
And you can set it to false or demonstrate.
Oh yeah, so within the script, which is... there it is. Yeah.
Oh, yep.
Yep. So that's just the Lua true value, Boolean value. It does duck typing, so that's going to turn that thing into a Boolean. Okay, so now we want to try to add in some Lua support so we can do some Lua interrogation back the other way. So let's just, I had some issues with this before when I try to work with it, so I'm just going to please work. So this is Cocos Builder. It's actually pretty cool how it works. Let's see, why is that so big? It's very, very big. So here's our bomb. And this screen real estate is going to be kind of a shame. And it's been set up as according to Victor's tutorial so that it's going to create a class called bomb inside of our code. Now there's no custom properties here, so let's go and create one. And we're going to call it the update script. It's going to be a string. And just for our testing purposes now, what we'll do is we're going to print we're going to print the game dot get position of self. So there's a little bit of Lua script that we've embedded into a program. You can imagine that someone who's not a techo level designer or whatever, they could be working with this, and they could actually, drop little pieces of script in like that. We've just got to have it actually get wired up and do something. You'll notice I've got this little prefix here, game dot, which is one of Lua's table accessors. So what I'm actually effectively doing by that is I'm going to say all of the API functions that I provide so that my game can be scripted are going to go inside of this little table of functions called game dot something. And the reason why you might want to do that is first off it'll be, you know, shoot bad guy, game dot chase or whatever, stuff that's most likely not going to clash. But you might wind up creating a function that just happens to be named as something the same as a standard lure function. All of a sudden, lure internally is calling your function. You might not ever see it, but you can actually clobber stuff if you overwrite global space. So that's why we stick stuff into our namespace like that. Yeah. So I've modified our
So
bomb.
is it the same as JavaScript in terms of like it's basically like a hierarchy of namespaces?
Very, very similar model. Yeah, yeah, yeah. So and it's got the same sort of thing where you've got this global thing that you can very easily access and very easily shoot yourself in the head.
And it looks like setup is basically the same as JavaScript as well, where you kind of run a file and that assigns functions like data to variable names, kind of thing. Is that
Yes, functions are first-class citizens in Lua, so you can easily create a function and assign it to a variable, etc., etc. So.
I would have known that JavaScript applies to Lua.
Yeah, it sounds like.
Okay, so we've added our script. We've hopefully published it into our program here. So I just need to make our Objective-C code actually handle that. First thing I need to do is make sure that when Cocos Builder sends us that update script, did I call it update script? Yes, update script. It actually finds a home, otherwise I'll get a runtime error from Objective-C. So it's going to put the update script. I could have put it into BOM, but BOM actually inherits from game object. And this way what I'm doing is saying, all my game objects can now be scriptable. Yay. A few strokes of the pen, pretty nice. So game objects can be scripted. Now what I have to do is find a way to actually get these scripts run during the game loop. And in the case of this particular little tutorial, the game loop happens here in this level.m, where it's looping through all of the children. Now here I update the position. So what I'm going to do is, I'm going to say, let's see, so I want to include my script engine again. Engine. Then I want to do it engine, shared engine, and I want to, let's see, we want to run script something with host, and that's going to be our game object. So you saw me use that word self. Self does not actually mean anything in Lua. I use that because I've done a bit of Python in the past. I quite like the self thing. And basically what that's doing is saying, when I run this script, I want to magically have some extra context, which is going to be the thing that had the script inside it in the first place. So I'm going to run the script with the thing that had the script inside of it. So that means my script can interrogate stuff about myself. So that's going to be handy. So that's what we need to implement.
So self is something you have to set up.
Yeah, exactly. Yep, yep. Unfortunately, that does not come for free. So our script is just going to be any string of the game object, and it's going to be the update script thing out of there. Now, of course, that could be nil if it's not set to anything, so we better check for that inside of our run the script method. So I've got up here, and inside of our word engine, we're going to have function run script, which is going to be in string, which would be a script, and we're going to run it with an object, with host, is that what I said? Which is going to be a game object. Host. I'll just do a, this is how you do straightforward declaration in Objective-C. Okay, so it looks happy. Now, our run script is actually going to be not too completely dissimilar. Run script post, and we're going to int is error equals lua l underscore do string this time with our lua state, and with a string which is going to be our script, and we're going to use the C string, the standard in string default body blah template stuff in there. Okay, and if there is an error, we'll complain about it by saying in this log of could not run script, the script, because of an error, which was our Lua error. And the script will be script, and the error will be Lua underscore toString of the state -1. Okay. Now, we're running our script, but what we need to do is get our host object into Lua. And this is a common issue every time you're working with some scripting framework. It's the problem of marshalling. Marshalling means I've got some stuff and it's over here on one side, and I've got to somehow get it into the other side. Lua has two ways of getting data into your program. It's light user data and, well, ordinary user data. Light user data is basically an opaque object. I don't know what it is. I'm not going to particularly do anything to it, but I'm just going to pass it around. The other kind is basically you're going to have to make up some way of telling Lua how to handle objects of that type. So we'll use the light user data in this case. So the first thing we're going to do, let's just make sure we don't have a null script first. Now this is one of the weird things about Objective-C that just makes you cringe when you first do it, is that you can actually send any kind of Objective-C message to null. And if you do that, what's going to happen is Objective-C will just give you a null value back silently, and it's completely happy with it. So there's no point in me saying, if script ampersand ampersand, you know, script length greater than, I don't have to bother doing that. I'm just going to ask it if its length is greater, and if it isn't, then I'm just going to get false.
So it's like in C, so 0 is null.
Yeah. So I'd get a, you know, just come back and give me the result I want. So, for an incredibly verbose language, there's sometimes when it can be succinct. But, okay, so let's get our data in. And what we're going to do is we're going to do Lua underscore push something. So we're going to push, which is what we want to do, and we're always going to push something onto the Lua stack. So we're going to push light user data, again with our Lua state, and we're going to push our host. We're just going to shove it in there and shove it into the stack. Okay, so there's a complaint, and the problem is that it doesn't know about a light user data function that takes a game object. It wants void star, so we've cast it to void star.
So are you pushing the pointer, or is it actually, are you going to give it a length so it pushes the whole object?
It's just going to push the pointer. So, yeah. So it's just going to push a pointer to the data. It's going to pass that around.
And that's the point of the light user data, isn't it? It's not going to, it doesn't care how big the object is or what's in it. It's just the point
It's
of the
a
object.
completely opaque thing. It's just pass it around, and then when I get it out the other side, I can then interrogate it. So now in this case, there'll be corollaries to this in whatever framework you're using, your Unity or JNI or whatever else. So you just have to try and understand what's happening here. Basically, I don't want Lua to hang on to this thing and manage memory. Lua is really, really good with memory management, and it manages its own retained cycles and reference counts and so on. But when I create this light user data, Objective-C is going to still keep managing my memory for me using automatic reference counting. So what I want to do is not choose the retain call. Instead, I just want to say, hey, just no change in ownership, thanks. So the magic for that is this little bridge cast here. And finally, I'm just going to create this as a global, similar to how we got the global just up above, the state, and it's going to be the global of, what do I call it, self, wasn't it? Okay, so now we've created a Lua variable that's going to be global, so it's not going to be scoped by, I could go and scope it into that other game table, but I won't. I'll just make it nice and easy so our syntax is simple. And it's going to have the content of our function. So I'm just aware that we're getting a little bit low on time, but I'll just press forward a little bit more quickly here. So the last things we need for this picture is to actually implement that function onto our actual game. We called it getPosition. So every time you create an API call into your game, you're going to use the same syntax, which is going to be, let's see, void getPosition. And it's going to be something that just takes a Lua underscore state. And it will return some integer value, in this case 2. Now that, believe it or not, is the function signature for every single function that you ever write in your API, whether it's a getter or a setter or just a utility function. It's always going to take a Lua state, and it's always going to return an integer. If it's a thing that returns values, it's going to push them on the stack, and that's going to be the number of items that Lua wants to get off the stack at the end. And we don't take any arguments in here, because everything's going to be passed to us via the stack. Stack in, stack out. So the actual function signature is always going to look like this.
Start with an int instead of void though?
Yeah, so it's going to be, exactly, thank you, good catch, rushing too much. So, yeah, so that's going to be our function signature. So it's going to be static, so it's going to be local. We're going to get function pointer, and we're going to give the function pointer to Lua.
This is, so actually you could probably go, so just for everyone really, I look at that and I straight away go, okay, you've now just given any script from data access to all of game memory. So that's an instant, that means anyone who can change the data for your game can now pull out anything from all of memory.
Yep.
Yeah. Wow. That's a big security hole if people can touch data in a project.
Yeah, well, I mean, I think, like what we did for Qt with the script processing there was basically whether you're running a script or whether you're running code, they both have the same sort of privileges. We didn't try to do any extra sandboxing or whatever. I really think like you can do some sort of sanity checking, but once you do the Vulkan mind meld with Lua, it's going to have access to everything. You just need to think about where those scripts are coming from, right? In this case, I'm not going to interpret any script that comes from outside of my program.
Yeah,
I mean,
so you have to,
if the guy who's running levels...
You have to be able to trust all your data that comes into your game.
That's right, yeah. You don't want to be interpreting script that's been passed to you by an end user.
I think you said before you ditched the compiler, but you might be able to pre-compile your code
and prevent that from happening at runtime.
You could easily
if
assign
somebody
text
if somebody
files
can
if you
change the
wanted
data
to.
for your project, for instance, if you're in a PC or a Mac project as opposed to an iPhone project, somebody can compile their own Lua and drop that in your folder, and as long as they can somehow change a reference to get it to load that up, or even just replace an existing object, they can even make themselves a wrapper around your object, if that makes sense.
I guess so. You're saying if they can dig into your data files and then replace a pre-compiled file. Yeah. So you have to trust your data in some way. So you maybe don't do this for serious banking application.
Yeah, it's.
I've got some stories on that front.
Yeah, I think trying to put layers of security, like if you're interpreting untrusted scripts, it's really the same as interpreting untrusted code, and that's the posture that Apple has with its App Store stuff. It's like they don't want to have scripted apps for that very reason, because basically it's really, really difficult. I mean, you can have sort of security stuff built into the interpreter and all this sort of thing. Lua is very simple, it's very lightweight, and it's very fast. It doesn't have any support for that kind of stuff.
So I guess the app signing comes into it as well, right?
Yeah, yeah. If you're going to have an update for your program that maybe has new Lua scripts in it, those scripts have to be secure in the same way as the rest of your app updates have to be. So. Oops, that's going to be actually this thing here. Okay, so we've got the similar sort of issue here again, where we're getting something out of this void star. So we're just going to bridge cast it again. Now we've got the problem here where, so basically, sorry, one of you guys made a very good point just before that yes, this is exactly right. We've got this opaque object. Now we get the opaque object back, and we've got our pointer to it. What if somebody forgot to pass in self as the argument? They passed in something else. So what we're going to do is just do a quick check here. Lua underscore is light user data L, because now we're using the one that's been passed into us, and it's going to be 1. In that case, we'll return nothing.
Does this actually completely fall over if you're if it's some other light user data and you try to cast it back to the
Yes,
same object?
that's right. I mean, this is very dumb error checking, and if you're exposing these APIs to a non-tech person who's doing your level editing for you, then you're going to want to try to do a lot of error checking here. I'm just saying error checking goes here. So yeah, you're absolutely right.
It's actually very difficult to deal with that kind of thing. When I was using Lua once, you would occasionally have these memory corruptions and stuff that were basically caused by a script programmer, because there was at the end of the day there's no way to know what you're getting.
When I was just thinking through the security stuff just before, instead of, by the look of it, since that pointer is basically opaque to Lua is just effectively using it as an identifier. I imagine if you actually instead used an ID system for your game objects, and so all of your game objects have an integer identifier between 1 and 40.
Dictionary or something as well.
Exactly right, and that way whenever you call back into this code, it can simply say, if you try and pass object identifier 41, oh, sorry, you can't touch that memory, it doesn't exist. So so you get your safety, plus you also stop people being able to. And I imagine, like, if this function, for instance, is sort of meant to be get the position of a certain type, and you've got 2 different types, you can probably validate the type based off your object ID. So you can probably wrap it or something like that, I imagine, to add the safety.
It's easy enough to control if you're doing everything from scratch.
Some of these binding frameworks try to do a lot of that stuff for you, but the thing that I like about this, the elegance of this, is you have complete control, right? Yes, there's a little bit of extra work to do up front, but you're the one that knows what kind of domain you're working in, so you can do the error checking that's appropriate. Like, the power of Lua is that it's so small and fast that you can just, you know, do without extra error checking, slowing everything down if you want. And in cases where you're sure you don't need it, then you can just elide that stuff.
Does Lua support user type? So you said, yeah, my light user data. Can you say, you know, I'm going to call this 3, or you know, give your own identifier and say this is now something? I haven't had enough Lua to.
Yeah, look, I haven't delved into that. There are quite a few ways to extend Lua, and I think you do have the ability, like the heavy user data thing, for example, you can, you know, add functionality to it. Lua's got a lot of meta programming functionality, so.
When you've got light user data, can Lua can't do anything to that data, right? That's just
That's right, exactly, yeah.
So there isn't actually anything the script can do with the component, is that true?
Not really, I mean, if you had a corrupt Lua engine, it could like go scribbling around in the memory, but it doesn't know anything about it.
Right, so if we take it, we'd have to replace the Lua interpreter as well.
Yeah, yeah.
You can make classes basically using the meta programming features, and sort of like basically like prototypal inheritance, what you get in JavaScript. You get that same kind of support. So you can, and some of the binding APIs you can get for it will actually, you know, like take your definition of a C++ class and basically build Lua tables that represent that and sync it up for you.
I'm aware that we're getting low on time, so I'll just see how far I can get with this. What I'm doing now is I'm just, the process of actually getting your function into Lua is non-trivial, but anybody's not familiar with C, this is just a standard C-style static structure initializer, so I'm declaring an array of function pointer. These are just structs that have a function pointer there and the name of the function pointer. It's terminated with nulls. Like
So there's a couple of code generator solutions out there which will basically like write this kind of
this is
code for you and compile it in.
Yeah, this is the sort of crappy boilerplate stuff that kind of is needed to get things in there. Okay, I think I'm out of time to go through this, but basically the way you do it is you create a little table with your function pointer, and I will mention one other quick trick here is that inside of Lua, I mentioned about the different Lua versions that come out, like 5.2.2 actually has quite a few new little features, and the way they control sort of version compatibility is they ship the new library with all the new features turned on and the old features basically sort of turned off, and there's a name of a funky macro which is Lua under compat under module. I just mentioned this because when I found this, it was, thank you, I wish I'd known about this ages ago. So basically what it does is when you've got this Lua compat module thing turned on, it gives you back some of these past functions and have changed the way they do things to the new version. And you go look online and you say, oh, in order to achieve what I need, I'm going to use Lua register and Lua, you know, these functions. You go to try to use it, it's not there, won't work, can't compile. Usually it's going to be because of these module definitions. So you just have to turn that on, and that'll make Lua give you back the old functionality that you used to have. Okay, so almost got that compiling, and it does work. We want to get another minute or two so we can just finish off the last little bit of this boilerplate. It's not too big, just typing this. So we've got our table of functions. Oops. We will have. So you can imagine that as your library of game functions gets bigger and bigger, this table is going to get, you know, extend off down the page of all the static functions that you're defining. You follow the same pattern. The way to get it into Lua is that you actually have to give Lua a Lua signature function like our get position one, and you then tell Lua to run the function that's going to load your library, because it's kind of weird. You pass it the function, and Lua reaches back out, grabs hold of your function pointer, and then pulls it in. It's kind of weird. You can't sort of shove the game library that you're writing in from the outside like you kind of want to. But it's very, very simple. So we just do inside of here, Lua register, our library, and we pass in, what is it? It's so this thing is the name, which is our namespace. And then finally, our table of functions. So it's going to do our registration for us. And of course, we have to return something. So the last thing we're going to do is when we open our libraries, we're going to run our own library. Which is going to be, so in order to do this, we actually have to go down here and run a much better place for it. So we can do Lua underscore push function, push C function, yes. The state, the function is going to be our Lua underscore open game library that we wrote. Now, Xcode is helpfully trying to complete that syntax, but I want the function pointer, not the actual call of the function. And then we want to Lua underscore push string onto our Lua state. And it's going to be the name of our library. So we're pushing two values, the same as we had with our table. We've got the name and the function pointer. And then finally we call our library. And you can see that this is a low-level function because there's no Lua under L there. The state. First thing on the stack, result nil. Okay. Now, when you download the stuff off of GitHub, you can just cut and paste. This is just boilerplate. This is almost always going to remain exactly the same. Let's see. We've loaded it. We've declared it. It's in the script. The chances of this working are almost nil. Let's see how far we get it. Build. Okay. Let's see. God. crash. Oh, how good am I? All right, so there's our get positions coming out of the script. So, all right, sorry for just running a little bit over time there. I want to leave some time for some questions. But so you can see that what's happening there is we are calling our Lewis script, and then our Lewis script is calling back to us, and we're marshalling data, we're interrogating game objects, and you can follow that same pattern to get to the point side of our final target, which is this thing here, where we've got our get position function. I created this little game distance function. This was really just to demonstrate stuff. So this is not actually interrogating any game object, but I'm doing some math inside of there where I subtract some points and do some square roots and things. Hey, why not do that inside of C? You know, Lua is pretty fast, but if you've got lots of chunky functionality, well, don't do that. You can create your own little utility functions for that stuff. And then, obviously, I follow the same sort of pattern as I did for the final, for our get position, where I just go and set stuff. Same exact function signature, take in a Lewis state, return some integers, get in our light user data, poke some stuff in, and that sets the value. As you can see, it's going to provide us with that chasing functionality. Let me just see if we can, this is still going to work for me. Oh. And now we've got bombs that chase us. Fly, little dragon, fly! Alright. Okay. So this here is the GitHub with all of my code and Victor's code. You can go download that and try that if you want. That's my email address, and this is my blog. Questions?
If you were to move that distance function to be a C function, would that be a more efficient way of doing it, or is the overhead of actually calling Lua and then calling back to C kind of two-sided there?
The overhead of calling Lua is actually really, really minimal. The marshalling costs are quite small. Those Lua does have to do like the meta-programming stuff. It's got to interrogate that. So there is, you know, some additional overhead, but Lua's performance is actually really, really pretty good. The main problem comes if you've got to do sort of looping or, you know, quite a lot of heavy logic. Not so much the math stuff, because, you know, if you're doing something like a square root, Lua is just going to call back into its own C implementation of that math stuff anyway. So I really did that distance function as a way to sort of demonstrate stuff. But say you were going to write like A star. Don't write A star in Lua, do it in C if you can. Thoughts, comments?
I was just going to say, where's been your most useful sort of application of it? Like, is it more, because you sort of did initialization and configuration, and you did sort of game logic of an object kind of thing. Which of those sort of areas is more useful, like the configuration and setup end, do you think, or the actual like object descriptor?
Being able to get values out of a text file is actually really pretty handy, just because of, you know, the game development pipeline. You know, I find myself working a lot with art assets and stuff, and I'm not always in, you know, my IDE developing the game, so I find it really handy to be able to just quickly tweak some text values in a script, and then, you know, rerun it without having to sort of recompile, rebuild my program. The biggest thing that's the most handiest stuff is, you know, pipeline collaboration with other people. At the moment I'm working on my game by myself, but I have, there's a couple of people I've approached and I've said, hey, you know, do you want some experience on a game? You know, and they said, oh, I'll do some writing for you. And I think by the time I get my second or third games, I'm definitely going to be working with other people. And in that case, you really want the ability to flexibly handle these scripts. All of my code gets checked into source control, but I manage my assets differently. And I kind of treat the scripts as kind of assets, even though they're text. Like the chat scripts that govern dialogues and games and all that kind of stuff, that kind of belongs into the creative side of my game design and the game development. And I want the flexibility to just quickly edit that stuff as a text file. And the dollar curly brace thing, I haven't seen that anywhere actually. Maybe I invented it, I'm really clever. I'm sure it's been done, but it's very obvious, right? You can just embed nice little chunks of script right in the middle of some text. It's so powerful. So, yeah.
It makes for a fast turnaround time when you're tweaking variables and stuff like that. When I first started using it, like, I think back on the PS2, I think it was when I started using Lua, and it was quite expensive to recompile and push that over to the console dev kit. And if you can make your engine sort of able to receive Lua dynamically, then you can, while the game is running, you can be actually tweaking scripts and playing with behaviour and not have to go through that rebuild and reload process.
Yep.
It's really cool.
Yep.
How do you go about hot loading? Is it a sort of case of actually killing your VM and recreating it, or
You can just run the scripts again in your VM. I mean, that's
sometimes not stop the old ones.
Yeah, it's going to have some weird side effects.
You just
sometimes.
reload the file, basically.
Just rerun the script within an existing VM.
So because it's like JavaScript, and you're executing it to initialize, so to speak. So when it executes function name this, it's going to stop the old one, and then garbage collect. It's garbage collect it, and then put the new one in place.
Yeah, exactly.
Yeah, because functions are first-class objects. So if you clobber some global variable that's assigned to a function name, that's just going to replace the old value with your new compiled string or whatever. So you saw those do-file and do-string functions that are called. Those are your bread and butter of getting your Lua to run. And what they're just going to do is compile stuff, and then you've then got to assign that to some global so that you can grab hold of it and use it.
Two questions for you. One is, a lot of the code that you're writing is very low level. It's push and pop this and that. Is that what you stick to yourself, or have you written yourself, or using a third-party wrapper, which just Lua state dot get parameter 0 as a string, some C++ or something?
So in my game that I showed you, I use exactly that approach that you saw there. My game API is quite small at the moment. So what I have is game objects have conditions and named conditions. So conditions are just open, closed, locked, unlocked, etc. So they're just a string. Named conditions are things like, I can't think of one offhand, but cleanliness state could be equal to dirty or clean or something like that. And in my my API is basically just has condition. So there's a has condition function. And if something has a condition, then in Lua I can interrogate that and do something with it. So what my experience was I didn't want some broad-reaching thing that was going to provide API bindings for everything in my program. I knew there was going to be quite a small handful of things. And I can always go and add new ones. I have the boilerplate there. And you're right that it is kind of a worry, and I do have to go back and refer to my cheat notes. Like, I haven't worked with Lewis for sort of 4 weeks. It's like, how the hell do I, oh yeah, okay. And
it's more of a C thing, is that wrapping it one level up, yourself in 100 lines of code or something might just simplify some of that stuff.
Yeah, well, like the code that I've written here is in the public domain, so just feel free to grab that and cut and paste it and use it, and that will get you most of the way. Like pushing and popping, globals, light user data, most of the things you want to do are in that set. There's some more power type stuff in the book, but honestly I don't think you really need it for the basic sort of game scripting that we're going to be doing.
Fair enough. How have you been debugging it? Just logging stuff, or are you using
log
debugging?
stuff, yeah. Like you saw, writing. I try to. it's so tempting when you're writing this code to not put in error checking, but I completely recommend writing as much error checking code around every step. Most of the problems that you have with Lua will be created by yourself. So just, you know, do sanity checks as much as you can all through the process to make sure. The Lua underscore is Boolean, is this, is that. You can interrogate quite a few things to find out stuff.
Lua actually has a really awesome API for writing debuggers, which is quite simple to write.
Andrew Bailey,
Andrew Bailey.
from Tennis, you were Tennis, weren't
He
you?
could have, but not when I was with him.
Oh, okay. A couple of years ago at a GDC, I think it was, I can't remember what the language was, and I'm pretty sure it was Lua. Andrew Bailey, who is one of those amazing, you know, idiots of art almost kind of guy programmers, wrote and fully open sourced a Lua debugger, I think it was, which he put a heap of effort into, and he launched it at the GDC, and I was such a happy.
There's at least one or two good ones around that should connect into your app and run.
Decoder is the one that was recently made open source. That's supposed to be quite good.
I think in the book there is actually some debugging support. When I'm working with most languages, I use the hi mum approach, you know, just hi mum 1, hi mum 2, hi mum 3, all through my code. So there's just a spew of crap coming out of my code all the time. And I find that works well for me. If I'm using threaded code, it's so hard to follow with a debugger. Graphical stuff makes debugging hard. I just find lots of stuff coming out of the console usually helps me. But if you prefer to work with a debugger, Lua does, like Ash was saying, have some hooks, and like you guys obviously, okay, if there's some powerful debuggers out there, you can do it that way. Most of the problems I've found with Lua are, it actually produces some pretty good error messages. So the most important thing is just to, you can write your own dump globals function, which I did. I just went to the web and said Lua dump globals, and it gave me a screen, and I pasted it in, and it just worked. So, yeah.
You can have your own like sort of command line based, you know, single step debugger, like with source mappings and stuff up and running in a day or two.
Cool.
If you don't have to write like a sophisticated UI, and it's actually a really, and not that you have to do that kind of thing anymore, but it's a really cool exercise in just learning how debuggers work and how you would write one.
Yeah, it's such a clean language, you know, both the implementation side and the actual syntax.
One thing that threw me out with Lua was if you declare a variable and you want to use that variable but you misspell it, it will create a new variable with the new misspelling that will just have null data, and it will allow anything. So why isn't it working?
I think
it's
you can turn on strict mode.
Yeah.
That will stop it doing that.
Oh, okay. I didn't know that. So I know you can do that with Perl, which I love, but I didn't think there was any way to do that, so I'll have to check into that.
Yeah.
All right. So like a strict mode.
I can't remember how you do it, but it might be something you have to set up in C.
Okay.
Then you have to use a bar keyword or something to do a declaration.
Yeah, I can't remember exactly. I've never actually used it because I've always sort of, you know, gone in a situation where there was little scripts in place and it never actually worked. Being able to turn that on.
Ah, right, because you have to.
There's so much code that didn't work then.
Something to turn on.
Yeah, exactly.
Just sort of coming out for the first time, it looks a lot like it's all of it seems to be almost assuming you're going to try and do everything in Lua, like the whole thing where, like it almost looks like it's expecting you to sort of not be shuffling objects back and forth, to just sort of be doing everything in Lua, and that you just want to come along and basically grab a couple of libraries and then run your magic binding generation code over them, and then and then you can just access them from Lua and do everything in Lua. Does that seem to be what the community, so to speak, of Lua people use it as?
Yeah, what I was hoping to do with this talk was basically, I know in the past where, like, people who've done bindings, for example, for Qt, for say Python and other languages, they use one of these binding generators, and promise, you know, hallelujah, there's a binding generator coming to save me, you know, that's all I need. But okay, that thing has two faces to it, and the second face is it's going to bog your program down and introduce new dependencies. You might then have a whole lot of extra overhead when you want to upgrade your version of Lua, you know. Like say one day Lua has a bug, these guys are really responsive, security problem, they introduce a new version, you want to upgrade to it, but your binding generator doesn't support it. What the hell do you do then? With this, all you're using is Lua itself, no dependencies, it's completely LGPL. And I was hoping, my hope with this talk was to demystify the whole process. I mean, my cheat notes, that I still use this whenever I need to go back to Lua. It's like one A4 sheet. It's so simple. Okay, there's some ugly boilerplate there, but I've given you the open source URL. You just cut and paste that stuff. You've got something that doesn't give you the overhead of a binding generator, and you can very quickly expose any functionality that you can reasonably want in your code. I can understand the desire to have something simple, but the reality is underneath there's a lot of complexity giving you that simplicity. So.
I'd like to make a point there too, because when we did scripting in games various times, I did some surveys of existing projects, commercial and open source, and found that the quantity of functions actually bound and used in games was often between tens and low hundreds. You didn't need to scan your whole thing, because the amount of work, if you sat down and did it, was minutes to an hour or so.
Yep.
It's not a big deal.
And once you get a couple of functions bound, finding a new one really just becomes, oh, it's like this and it's like that, and I'm passing back one of these, fine.
I guess that might be helpful if you've got a mix of different people as well. Like if you've run a tool that's exposed all of the low-level internals to the scripting language, then you hand that over to story writers or artists or whoever. They might be using things that the coders don't want to use, and then you've got to worry about visibility of your game engine. Whereas if you're doing it by hand, you know that some programmer made that available, so be it on their heads. Right?
And if your artists, your content creator guys, if they come back to you and say, oh look, I absolutely need this, you can just go back in and add it. It's sort of, Otherwise you say to them, oh, here's all of my bound functions, 3,812 functions, including a whole bunch of stuff that you never heard of, that you don't need.
You probably shouldn't call.
You shouldn't call.
26 that are almost the same.
Yeah.
There is actually a way to get access to pretty much everything without having any bindings at all, and I wouldn't really recommend this, and I can't remember what the project is, but there's this C library, it's like an extension to Lua, that allows you to load DLLs and call exported functions directly. So effectively it gives you access to pretty much anything. It's, for security reasons it's pretty dangerous really, but if you wanted to script your entire application in Lua, you could use that. So then what you have is a very sort of thin C shell running Lua and this other project. And what I've seen done as well on top of that is a way to basically sort of read in a definition of a COM class and actually generate the bindings in Lua using this low-level library to basically access any instantiate and access functions on COM objects. And so I've seen that used, but it's dangerous for security, and it's really, in my experience as well, it's really easy to corrupt your stack or memory from Lua.
By the time you're doing that, it's no longer being a scripting language. It's trying to be a real language. It's trying to be a full language where you can just do anything.
It feels very model-view controller, doesn't it? You keep your views simple and expose what they mean.
Well, this is what I said at the beginning when I was talking about the scope of this. It's you're trying to add the power of scripting to your existing game. You're not, and if you've got asset creation guys, they probably don't want all that extra stuff anyway. So.
Sarah, did you end up using coroutines to do asynchronous type scripts?
I have been reading up about coroutines, and they're really kind of a cool idea. It sort of looks like a thread, and I think you can actually back it up so it actually really is performing like a thread. It's like multi-processing.
They're actually really awesome in games for doing sort of ongoing cutscenes or objective systems, where you basically you can sort of yield the coroutine until some sort of combination of conditions become true, and then you continue executing it.
Right. So the door opens, but it's blocked by something. You can tell everything's blocked. Oh, then you can continue.
And every update, you just revisit that to see if the script can continue running.
Or even just anything that animates. So walk to door, then open door. That would normally be a whole bunch of stuff. Just maybe 2 lines of code now.
For those kind of situations, does it have a way to sort of save off state and switch context, or does that mean you then still need a VM per thing that can block, if that makes sense?
Yeah,
We need to put mutex around that Lua state, or have separate Lua states.
it's cooperative, so there's just a separate stack frame per logical thread per coroutine.
Right.
That's it. So that you pay the cost in a little bit of memory for each one. Really.
because the point it maintains a state and it's ready to continue on when you get back to it.
So you can have multiple stacks running within one VM.
Yes.
Yeah, that's right. Yeah, so a Lewis stack's like the moral equivalent of threads. It's got its own functional quality.
But without any of the complexity, because it is sort of sequential with this system. Or, yeah. You don't get anything out of order. So, enjoy.
I think we better wrap up, eh? Round of applause, sir.